Have you ever stopped to think about how an app could possibly take something as, fuzzy as personality and turn it into cold, hard data a computer can work with? Well, today we're going to tear down a piece of software that does exactly that. We're not just going to look at what it does. We're peeling back the layers of the code to see precisely how it's built. And this, right here, is the million-dollar question for this whole explainer. We all use phrases like a good fit for a job. But how do you actually program that? How do you take a concept like compatibility, quantify it, and then write code that can measure it? That is the exact problem this little application is trying to solve. Okay, so what's the big idea? Well, the project's own documentation, the README file, puts it pretty plainly. The key phrase to latch onto here is trait-based analysis. The system isn't just guessing. It's designed from the ground up to break a personality down into smaller, measurable pieces. And that's our entry point for understanding everything else. Right. So before you can even think about matching personalities, you first need a way to define them, to measure them. This entire system, all of its logic, is built on top of one single core concept: the trait. Let's see how they do it. What's so cool about this is just how simple it is. Every single personality trait in this system gets plotted on what's basically a two-dimensional map. You've got one axis for friendliness, going from -10 to +10, and another axis for dominance. So every single characteristic is just a coordinate, a point on this map. And here's where that abstract idea becomes totally concrete data. We're looking right at the file that populates the database, populate_traits_db.py. You can see that a leader is way up there, a 9 for both friendliness and dominance. Meanwhile, reserved is much lower, a 2 and a 3. Every word gets its own unique numerical identity. And how does this look in the actual code? Oh, it's beautiful. It's this incredibly simple Python data class, right from the personalitymodels.py file. A personality is nothing more than an object that holds two numbers. That's it. This is the fundamental building block that the entire application rests on. Okay, so we've got our building blocks. We understand what a trait is. Now, let's follow the journey. How does a person's profile actually get created and analyzed inside this system? For this, we're going to need a volunteer. So, let's meet Bob. We're going to create a brand new profile for Bob and watch exactly how the system takes a simple human description of him and turns it into data. So this is literally what you type into your terminal. No fancy interface, just clean, direct commands. First, you create the profile for Bob. Then you add a description using just a few choice words: outgoing, assertive leader. Now behind the curtain, the application grabs that string of text, it splits it into individual words, and for each word, it looks up the corresponding trait in its database. Then it uses those scores to calculate one final overall personality profile for Bob. Let's see how that last part works. All right, this is the heart of it all. This is the aha moment. We've got Bob's profile, and we've got a job description. How does the system figure out if they're a good match? Well, it all comes down to a really classic, really elegant bit of math. So here's the scenario. On one side, you have Bob. His personality is basically an average of the scores for outgoing, assertive, and leader. On the other side, you have this job at Sales Corp, which is looking for its own ideal personality, based on words like charismatic and team player. So we've got two different points on our personality map. The question is, how far apart are they? The answer is something called Euclidean distance. Now, don't let the name scare you. It's the same math you probably learned in school to find the longest side of a right-angled triangle. It's just a way to measure the straight line distance between 2 points. And in our case, those 2 points are Bob's personality and the job's ideal personality. And here's the exact code that makes it happen, pulled right out of the company's service.py file. It's just so clean. It takes in 2 personality objects, plugs their friendliness and dominance coordinates into this distance.euclidean function, and it spits out a single number. And here's the magic. The closer those 2 personalities are on the map, the smaller that number will be. And there it is, the result. The calculated distance between Bob and that job at Sales Corp is 1.23. In this world, a lower score is always better. It means Bob's profile is a really close match to what that company is looking for. So we've seen the core logic, that clever little algorithm, but a really solid application is so much more than that. How is this system actually put together? How is it organized to be manageable and easy to understand? Let's zoom out and take a look at the architecture.
This shows you the path a single request takes through the system. It all starts with the user typing at the command line. But that command doesn't just go straight to the database. No, first it's caught by a command handler, which is like a traffic cop. That handler passes it to the service layer, which has all the business logic. It's the brains of the operation. Now, to do its job, the service asks for data from the data access layer, or DAO, which is the only part of the whole system that's allowed to talk to the database. This clean separation is the hallmark of really great design.
And this all comes down to a critical idea in software engineering called separation of concerns. Think of it this way. The service layer has the brains. It knows the rules, like how do I match a person to a job? The DAO layer, on the other hand, has the hands. It only knows how to get stuff from the database. It asks, how do I grab all the person records? By keeping these two jobs completely separate, the code becomes so much cleaner and way easier to manage down the road. Okay, so we've torn this whole application down. What are the big ideas we should walk away with? Let's just quickly summarize the key lessons and maybe touch on what this kind of technology really means. First, we saw that clean architecture isn't just some academic theory. Separating your logic from your data access makes a real tangible difference. Second, this was just a fantastic example of using math to model a really abstract concept like compatibility. And finally, we learned that the code itself is the ultimate blueprint. If you want to understand how a system truly works, read the code. And that brings us to one last, really important thought. This project is a fascinating technical achievement, it really is, but it also cracks open a much, much bigger conversation. When we start building tools that can put a number on something as personal as, well, personality, what are the implications? What are the risks and the ethical questions we have to start asking ourselves? And that's a question that goes way beyond just the code itself.